Can see my screen. Can you confirm you can see my screen?
Yes, we can
So,
see your screen.
okay, before I proceed, how many of us have created an AWS account? Do you have any hiccups so far on creating the account? What's going on?
So I had the account already, but
Okay.
I've really been down in my health, so I've not really done anything the past days. I'm
No, you don't need to do
ref-
anything. I don't need you to create the account. So if you have the account, the account is based on the account is really relevant for the next task we'll do. So that's why I wanted to create it and keep first.
and the last class you talked about that it accepts only
Yeah, USD card.
only yeah, but I used Access Visa card. It
It
accepted it.
worked. Okay, that's
Yes.
nice. You know that this CBN rule that they just removed recently, probably that's what made it work.
Okay.
Because to try last year, I can beat my chest because even in the last training that we did for DevOps in Codehouse, they could not open in
Okay.
Nigeria if the Naira
You know,
card. I was very shocked.
I opened a free demo account, not
Okay,
the one that.
free tier account.
Yes, I have an open
Okay.
free tier account.
All right. Does anybody have any other issue? Before we
Yes,
proceed.
good evening, sir.
Good evening.
I'm trying to create the account, but it's not accepting my card. I'm using a Senate Bank. So,
Please,
boy,
who is the guy? Who is the person that said he? Who is the person that said he used Access Bank card? I beg. Someone just spoke now that they use Access Bank card. Please, I didn't see your name. Identify yourself.
So it's me, Elijah.
Elijah.
Yes, sir.
Okay, you're the one that created the Zenith Bank card.
Access Bank.
I'm talking about the person. Someone just talked now previously that he created the Access Bank Visa card.
Yes, I'm the one now. I'm the one with Access Bank Visa card.
But your account is working perfectly.
Yes.
Okay, who is the person that's just complaining about Zenith Bank now?
it's me, Isaac.
Okay, can you reach out to Elijah, I beg? I don't know. Probably it's just the you can try other. You can also try using other banks. But if Access Bank Naira card, Visa card can work, your
No,
Zenith Bank,
I use Mastercard.
and you can try using if you have another account, then you can try using it.
Okay,
Mm,
thank you, sir.
thank you. So, what are we talking about today? AWS. Let's move forward. There are 17 people on this call, but yes, people are quiet as much as I don't know. People don't contribute, people don't say anything. So at the end of the class, people will do your assignment. It's okay. There's one person I'm going to call out at the end of this class. This guy is just a quiet genius that is just doing his assignment. The assignment is literally 100% every single time, and I've identified his name. I think the last class, I said that it was somebody, but now I've seen the person, and he's in this class. But anyways, let's move forward. This guy is good. Like he won't say anything in the class, but his assignments are speak spoke, clean. Anyways, this is AWS environment, yeah. So AWS is a cloud computing platform that helps to, you know, that's And it basically gives you compute resources, database resources, and all sorts of IT related resources on the cloud. So think of yourself as an IT person that wants to probably do some connections, probably wants to do some networking, probably wants to do some, just IT related stuff, but you don't want to spend time to go and start buying servers. You don't want to spend time to go and start trying to set up a database. You don't want to spend time trying to even do networking, trying to figure out subnets and all those whatnot by yourself, which is what traditional IT has always been before the existence of cloud. That's what cloud does. So cloud gives you resources that you will normally pay for, that you will normally buy and configure by yourself. They give you access to these resources. However, the thing with cloud computing is that it is a what? It is a pay-as-you-go service. So, yeah, I'll let people know. Don't worry. At the end of the class, I'll let people know. So that being said, so there are multiple resources that you will be familiar with. Now, this is the AWS environment. So one thing you need to understand about cloud is that just take yourself as, okay, you want to configure resources, but you don't want to start going to buy server. You don't want to start. So that's the whole concept with cloud computing. So I didn't want to write any slides. Let us talk. Cloud computing is basically like, setting up systems is basically computing, having systems that are running on, running in a particular region, a particular environment. What you just do is to borrow, you're basically just renting part of their resources and you're paying per hour. So it works in a pay-as-you-go scenario where for every hour you use those resources, you get to pay for it. So that's what it is. There are some underlying concepts around AWS. Hold on. So underlying concept around AWS. Now we are seeing when you open your account for the first time, well, let's see how it goes then. If the person doesn't want to be known, no wahala. But let's see how it goes. But I can identify him in the call on the call here. Anyways, moving forward. So cloud computing is basically like delivering cloud computing services through the cloud. So when you say through the cloud, it's referred to as over the internet. You understand? So I want a server. Now instead of me to go and start buying server and start configuring it and connecting to it through probably local area networks, I can go and get a server that I can connect to via the internet. So the fact that it is on the internet is what now makes it the cloud. You get? So there are resources, there are computing services like servers, storage, database, networking, software, analytics, and just basic, IT related resources over the cloud. And it's very good because it's going to save you time. In as much as it may not save you money, but because it's also a bit expensive because you're paying per hour, but it will save you a lot of time that you use to get stuff together. So as an engineer, if you can, your team can afford it, cloud computing is the best because you are practically dealing with, get everything, the underlying setups done for you. You just need to, get what you can. So if you want a 2 gig server now, you can just easily go and get a 2 gig server, just like what I explained to you in the last class. You can get T2 micro or T2 medium with their configurations, and you can get a server for free, basically. So cloud computing is on demand and comes with a pay-as-you-go pricing. Pay as you go. You understand? It's just like it's not like prepaid that you pay, let me say you pay 1K and then you now keep on using that 1K to the finishes. No. Cloud computing is a pay-as-you-go model. So the more you use your resources, the more your bill keeps piling. Piling. At the end of the month, they send you bill into your email. So yeah, it is good because it's on demand. So cloud computing is basically on demand service. You understand? With with the presence of cloud computing, users can provision resources automatically and access these resources anywhere in the internet with proper security configurations. So you can set your resources that allow anybody in the internet to access, and you can do it. You can also set your resources to allow only the people that are connected to my corporate network to access. So configurations are easy because you won't have to deal with a lot of stuff. You get there's shared infrastructure. So with cloud computing, you deal with a lot of shared infrastructure. So you have an infrastructure that you can you can share among different customers. Now, the good thing about the cloud environment is that you can also implement elasticity. You understand? So elasticity simply means um you can scale resources up and down based on demand. You can scale resources up and down based on demand. So if traffic is high, for example, now let's paint a scenario. You deploy an application to your server in your office. By the time you want to do all the configurations to ensure that people are able to access that server through the internet, that one will take more work. Now you manage to do that work. You now have a situation where the traffic to your application is very heavy and there's a lot of traffic. To now scale, you now have to start buying another server to connect with this one so that the resources can be shared so that to manage the traffic. It will take you time, it will take you money, it will take you energy, it will take you brain work. But the good thing about cloud resources is that you will only have to deal with um you can create a server in one click and a new server will be created. You can create a server in one click, a new server will be created. You can create a load balancer. It's very difficult to configure a load balancer self manually with a normal server. But on AWS, you can create a load balancer. Now you can put a load balancer in between your two servers and it will route traffic for you easily. That's the good part of cloud computing. Now, there are some fundamental concepts that we will need to know before going to AWS. There are some fundamental concepts. Fundamental concepts. Now, there are different types of cloud computing. One, there is infrastructure as a service. If you're writing, write it down because there's no slide. There's infrastructure as a service. Now, what infrastructure as a service does is that it provides you infrastructure. That's what it means. The part of the cloud computing that provides infrastructure, it means that this particular part provides you infrastructure. Your work is now to configure the infrastructure to your taste to deploy the application. That is what I did with Amazon EC2 last Friday. What I did was I got a server of what? 8 gig storage, 2 gig RAM. I now got it. I now entered into this infrastructure and I tried operating it by myself, which is to run all those sudo app updates, sudo apps, install XYZ, Kiniki. That service is called infrastructure as code. Now there's also platform as I say infrastructure as code, infrastructure as a service. Then there's also platform as a service. Now, what platform as a service does is that it gives you platforms that are already configured for you. So the good part is that unlike infrastructure as code, where it just give you the infrastructure you configure by yourself, platform as a why am I always saying infrastructure as code? Because of infrastructure as a service, it will give you infrastructure where you configure by yourself. Platform as a service, on the other hand, gives you already configured platforms. So unlike infrastructure as code, where you just give you the server, you have to configure the internals of the server to deploy your application. What platform as a service does is that it gives you the platform where you will just deploy and manage your applications. You don't need to work on the underlying engineering. You understand? Most people prefer it, but it also has its own pros and cons. The pros is that you won't have to think of anything related to management, system management. The cons is that it is not dynamic. So if something happens to your infrastructure, you cannot go in and find the root cause and come out. That's what platform as a service does. I'm sure most of you that are familiar with front end, you could do use stuff like Heroku, use stuff like Vercel, and all those stuff. Those are platform as a service. Because why? They will just give you everything. Once you push your code, bam, your code is running. They give you URL, you open, you see your server. You don't know what is going on under. That's what AWS also provides for you. And their platform as a service called Elastic Beanstalk. We won't it's out of the scope of our training. Then there's software as a service. Software as a service is delivering software through the internet. So cloud platforms that give you software through the internet. Already designed software. You don't need to deploy anything, you don't need to manage any engineering. You already just have the software on the internet. That's software as a service. Now, a typical example of software as a service is your Gmail on Google Cloud. That software that is provided by the cloud platform that you just use, probably just sign in and use. That is what a software as a service is. Now, there are three kinds of cloud deployment model. There is a public cloud, which is AWS and the rest of them. AWS, Google Cloud, Azure, they are all called what? Public cloud. So when they ask you, what is your preferred public cloud? What's your preferred public cloud? And this thing, you say AWS is my preferred public cloud. AWS is a public cloud. Now, private cloud. Private cloud is the one that is embedded within organization, so it does not reach out. So if you want to deploy internal apps that are useful internally, that's where you use private cloud. That's where tools like VMware Tanzu, I'm sure you can go and Google that. Tools like VMware Tanzu are useful for. Those ones they can use to provide private infrastructure, and it's very useful when you're working in all these banks, governments. It's very hard to see, except a few of them that can properly manage it. But most banks they use private infrastructure. Then there's hybrid. So hybrid is what is a combination. So you can build applications where one part of the application is on AWS, while the other part is hosted on your private cloud. That's what they call a hybrid cloud infrastructure. So yeah. Now coming to AWS, you can see my desk, you can see my environment. You can see my environment now. My environment on my screen is AWS. So they are very, 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 very key. There are just some key services that we'll touch for the purpose of this training. We'll first of all touch the EC2, which we have already touched on Friday. The next we will touch um, VPC. After VPC, we will touch IAM. So IAM is the entry point of security of the cloud. So VPC is okay. We can also touch RDS, but that one is later. So we're touching EC2, RDS, EC2, RDS, IAM, VPC, and S3. That be very yes, S3. Yeah. We'll touch S3 definitely. So EC2 is Elastic Cloud Compute, or some people confuse it as Elastic Compute Cloud, depending on what rocks your boat. But corporately, it's Elastic Compute Cloud. Now, EC2 is a web service that provides secure and reliable compute capacity. You understand? Infrastructure as a service. That is what EC2 does. It helps you to launch virtual machines that run applications like a physical server. Infrastructure as a service. Note, infrastructure as a service. So imagine now you're already familiar with Vagrant. Most of you that did your application, that did your stuff very well, you're familiar with Vagrant. And see that whole setup of Vagrant. So imagine you not setting up Vagrant. You go to EC2 and get a server and running it and do whatever you want to do with it. You can set up a Windows server, you can set up a Linux server, you can set up a Mac server, any type, because it is rent. So think of it as renting a server in the cloud. But however, you can stop it at any time. You can start it at any time. You can choose any operating system at any time. You can scale it up and down based on traffic. That is the benefit of infrastructure as a service using EC2. With EC2s, there's elasticity where you can scale up and down depending on your needs. There's a choice of OS. You can use any operating system at all, Linux, Windows, Mac, anyways. There's the instance type where you can choose the comp. So unlike when you go to the market now, if you buy a 2 gig server, if you want to upgrade that 2 gig server, it is hard to upgrade the 2 gig server. You understand? For those of you that have done traditional IT before, it's not easy to upgrade a 2 gig server to a 4 gig, especially when you're doing all those things. You have to start buying, extra RAM and all those things. Okay, think of your laptop now as a typical server. Let's just use that one. Your laptop is a 2 gig RAM. When you want to upgrade to a 4 gig RAM, what do? You go to the market and you buy another 2 gig RAM and add it. That whole complexity of trying to open your laptop, trying to find where the thing is, trying to, that whole complexity, AWS removes it from you because with one click, you can easily, upgrade. You can move from one instance class to another, and you can get stuff done. Security, you can secure your application using key pairs, like I mentioned in last class, IAM rules, security groups. Storage options, there's Elastic Block Store. So storage option is like your flash drive, the hard disks of your laptop. That your hard disks of your laptop, that's what storage is. So when I talk of storage, that's your hard disk of your laptop. Now, it also has a pay-as-you-go pricing as well. So, let's take a look at the EC2. So the EC2 now, there is let's see, this is how our EC2, I think I've explained it. And then first of all, there are AMIs. So AMIs are the operating system and software configuration used to launch an instance. You can have your own AMI that you can create, or you can create you can use the community AMI, which is the ones that we created last time when we used Linux AMI Windows. So AMI is particularly like the operating system. So it's like, let's use the main, let's use the, I always, if you notice my teaching, I always like using scenarios where people can relate to on a, on a lane level. Let's say you want to upgrade your laptop now from Windows 10 to Windows 11. You understand? You go to a computer shop. What do the computer guy do? They will can carry a CD that has Windows 11 and put in your laptop and start all those booting process. Or they can carry a flash drive and put. What is contained in that flash drive that they are putting to do that upgrade or to set up your laptop is called the AMI. People understand that. That is what they call it. That's what we refer to in cloud computing as the AMI. It's not the AMI in the flash show. Talking about that whole concept now. So when we want to create a server, we go and get an AMI, which is a Linux AMI, a Windows AMI, a Mac AMI. We use it to create the server, and it then turns to the operating system of that server. So when you go to repair your laptop, oh, okay, I want to put Windows 11 for this laptop. They will pull out a disk, a flash, connect it, do all their stuff. What is contained, the file that is contained in that flash is synonymous to what we call an AMI in cloud computing. You understand? understand me? Are you people understanding the concept? Are you people understanding the concept? Okay. Oh. There are 17 people in this class, but only one person or two people are responding. No one. Now there are instance types. There's an instance type here. There's the instance type here. There's the T2 micro. The T2 micro is the smallest instance type. For you, those of you that are creating uh your account for the first time. Okay, thank God. For those of you that are creating your account for the first time, you will see T2 micro, you see free tier eligible. So free tier eligible, the T, anything T is basic level. They call it, but they call them bustable instance because they are like the small types of instance that you use for probably testing workloads. You understand? They are optimized for just small scale development and configuration. They're not used for high-end stuff. Then the M is for large. So the M is for general purpose. You get. Then the C is for compute optimized. Like that, there are a lot of them. Then you can have the different sizes at the end. Starting from there's nano all the way to 64x large self. If there's even not higher. So it depends on your compute need. Recently, for one of my projects, I deployed a server. The server was hardcore compute optimized database. It was a database they asked me to deploy. The database was 12x large with, can't you remember the configuration they asked me? 12x large, 300 and something. I can't remember. 2 terabytes of hard drive storage. 2 terabytes of storage. Omo, when the bill came out for that, this thing was almost 20 something thousand dollars for the bill for that database. Even me that was deployed. It's not my money they're going to spend. It's just me that they told to deploy it. Even me that deployed it, I was already shaking. Because you know now, typical Nigerian on that kind of money. So, so yeah, it's a lot. That's just what storage is. Now there's a key pair. There's a key pair. Key pair is used for SSH access. There's a key pair here. I'm showing you key pairs. No, key pairs are no longer shown. Okay, look at it here. Key pairs. So these are the key pairs. They are used for SSH access. Like I said, the key pair provides a public and private, you know, duplication. So when you create a server and you use a key pair, the private own stays in your server, and then the public own gets downloaded. The public own gets downloaded to your local machine. So when you're trying to SSH, which is secure shell access into the server, it will do like a pairing. Once the public key and the private key pair match, that's when your server gets access. If the two of them don't match, they'll tell you connection refused. You understand? That's what your key pair does. And security group. Security group is like the firewall. The way you have firewalls on your normal server, that's what security groups are to your cloud servers. They act like a normal virtual firewall to control traffic in and out of your instance. Then there's an elastic IP, there's EBS. Elastic IP is static public IP that you can assign to your instance. I explained it last week that when you start start a server, the IP address will automatically change. So the best thing people will do is that they'll create IP addresses, elastic IP addresses, and connect to that server so that if anything happens, the server goes down and comes up again, the IP address remains stable. That's what elastic IP addresses are. However, they are expensive because they run per hour. So that being said, there's Elastic Block Store. So this is a block store This is a block store. These are volumes. And these volumes now are like your hard drive. The way you have hard drive, these are what volumes are. So when you create a server, you set a what? A 12 gig hard drive. Let's just say we're using normal this thing and we set a what? 256 gig hard drive. Connect it to your server. You understand? When you log in, you check the memory, you check the storage, you see this is 200. So anything you want to store inside, just like how you have your normal laptop. Take your laptop as a typical server. Most of the components in your laptop is what you see inside because your laptop is a server basically, the smallest server you can work with. Yeah. So when you keep things on your server, if it exceeds that amount, it will just stop. It will give you a warning that, oh, you're exceeding the normal memory limit of this server, blah blah blah. So that's what it is. Yeah. So these are just theoretical concepts. I've already explained EC2s in depth. Let's go over to S3. Let's move over to S3. We're being dynamic here. We're not going to use S3 for the purpose of this course. So I'm not going to use S3 for the purpose of this training, but it's just good to know it. You get. So what is S3? S3 is object storage service. Object storage, emphasis on object storage. Now, AWS, there are different kinds of storage. There's block storage, which is what you have as your hard disks, which is your volumes. You get. There's object storage, which is your S3. There's file storage, which is your EFS, Elastic File System, out of scope. Then there is databases, which is your normal, this is your database. You understand? Database is also a type of storage. You understand? So it depends. These are all the concepts, depend on what you want to use them for, the kind of storage you need at a particular point. That is what this thing is. Now, it is a highly scalable object storage service. With S3, you can store and retrieve data at any time. It is used for object storage. Let me tell you a kind of object: images, videos, backups, logs, etc, etc, etc. If you have an image, if your application now, for example, now has an image that you want to put, for example, you are building a front end, you get, or rather, your engineer is building a front end. And the front end has what they call gallery, where they will store all the pictures, They store all the pictures. How do you think that picture? How do you think that picture is saved? S3. If you're deploying with, if you're deploying with, you're deploying the application on EC2. Now, what S3 does is that S3 creates what is called a pre-signed URL. So that pre-signed URL is what so if for each thing you upload to generate a pre-signed URL, then you now attach it to your code, or the developer will attach it to their code. So when they open the site, or S3 said you can just way if your bucket is public, it's a way you can even get a URL, so attach it to your code base. And then when they open the site, they will see, when it gets to that part of the code, they will see the image that is stored in the bucket. So that's a typical scenario of a bucket. All these ones are just my bucket names when I've been playing around with projects. Ezekiel, Kini. Yeah, I need to even clear all of them because most of them are not useful. There's now one thing with buckets is that you cannot repeat name. So bucket names are global. So if I use Ezekiel Umesi now, I cannot use Ezekiel Umesi again. except if Ezekiel Omisi bucket does not exist in the world. Now, if I use Ezekiel Omisi in Nigeria, someone in Australia in his own AWS account cannot use Ezekiel Omisi again to create a bucket. That's what they call a global name. The names are globally unique. That's the English I was looking for. The names are globally unique. You understand? So, like this Ezekiel bucket text track, now as I've registered this name here, nobody can use this name again in the world. Nobody can use this name again in the world. The names are what globally unique. That's why you can see you don't just name the bucket anyhow. Sometimes you can even put number. See how long this number is. That's how the buckets are. So yeah, typical example of a bucket. If you check a typical bucket, you will really see just files like code base basically that I use it to store. So the kind of files that S3 stores is kind of files that you don't want to impute in your code. You just want the file to be stored. So when I say you can also store files, there's some files that you just want to keep on your you also to store it. Probably is a production code. You just want to store it. That's when you use S3. But for file storage, there's a particular EFS, Elastic File Store. You save files there that are configurations. So if you want to like mount those files to your server, so instead of writing the code again, you can save it as a file on EFS and mount it to your server. So it will go to that file and pick from the file there to run it. That's what an Elastic File Store, but that was out of scope. This one is just to store. It's just a basic storage. You understand? You can create a video. If you come here, you create a bucket, general purpose. I've not created a bucket in a while though, AWS. To permit me if I'm rocky. I use multiple cloud providers, so sometimes things they touch my head. So let's do this. Bucket name Ezekiel. If you check now, if I leave this environment, what will it tell me? It's not even bring out the error yet. It's when you want to load. Let's just say my Ezekiel, my practice. I don't think anybody has taken this name. 25, which is 2025. Copy, now I tell you copy settings from an existing bucket. Object ownership, ACL, which is control lists. These are the controls that is. You can see all objects in this bucket are owned by this account. Access to this bucket and is specified using only policies. Objects in this bucket are owned by other accounts. Access in this bucket can be so with ACL enabled, you can do multiple account ownership. But we are going to disable it because I want it to be in my account. Now there's block all public access. I'm not going to block it because I want the bucket to be public, but it's not ideal. There's sometimes when you want to create a bucket that you want only your internal team to use. That's when you will do this and then write what is called IAM. Bucket versioning. Now, what bucket versioning is that once you delete an item in the bucket, it's a bit to complete. No, bucket versioning is if I have a particular, let me say a particular video, you understand? If there's versioning enabled on the bucket, if I upload that video again, it's not going to overwrite the old one. It's just going to create a new version of this same video. So if, for example, now I don't want the new version, I want to go back to the old version, I can just easily switch back to the old version. But if you disable bucket versioning, if you upload the same document, probably want to upload a second time, to go and remove the old one that is there and put this one to replace it. Yeah, I have to see enable. Then there's tag. You can tag your tag is just like labeling basically. So your key will be name, then the value will be my bucket. Let's just say my Ezekiel bucket. I'm not going to do hands-on like this for the rest too. So I'm just trying to explain. Now there's encryption. So encryption is very important. Server-side encryption to encrypt the details so that it is secure. So anything you store in the bucket, it must be secure. There's a particular encryption mechanism called KMS, but S3 also has their own miniature encryption mechanism, which is SSE S3. So we're going to use that one for now. If you use KMS and this one, oh, pricing, advanced settings. This one we don't need it. Now we can just do create buckets. Now you can see it's creating bucket because the name that we use is unique. It's not going to give us error. That's the sign. If we do not use a unique name, oh, what you have just seen is what you will have just seen is probably um sorry, but this name cannot be used type of stuff. So that's what it is. Um you can see the name of you can see my bucket here. Physical practice. Let's upload something inside. Upload. Add files. But click on add files now. My can people see? Okay, don't worry. Let's just say image one. So this is image one I've uploaded. Let's okay, so upload it. You can see status pending. It's uploading. You can see it. Image one. If you open the file, it's opening S3 management console. It's opening the file inside the bucket. So you can see to secure my practice, you can see image one here. You can see object URL. Since we are doing a public, the app bucket is open to the public, you can open the object URL. Oh, it's giving me access denied. Mm. Those are some extra settings, permissions. Look at it. I probably did not click the right link. Look at it here. Look at the image. This is just a screenshot of my Slack work. But yeah, so you can see now it has opened the image basically for us. Now let's move forward. So basically, yeah, in a nutshell, I go talk rubbish. In a nutshell, this is what we are doing with S3. Now, next one is IAM. What is IAM? IAM is Identity and Access Management. This is the security. This is practically the gate man of this your cloud environment. Anything you set here will be used against you. Anything you set in IAM will be used against you as a cloud engineer. So what is IAM? Identity and Access Management? It's a secure access control service that helps you manage users, groups, roles, and permissions in AWS. That's why I said anything you set here will be used against you in the court of law. I don't know. I feel like someone should write this thing down. Anything you set in IAM will be used against you in the court of law. For example, here you create users. There are users here. These users are the people that have access to this account. I'm not going to create a user. These are all my users over the years. I use this. Which one am I even using? These are users, but I'm using my root account. So in AWS, there's the root account, which is your master user, the person that owns the account. In some companies, the root user can be the corporate organization. Then when you get a job as a DevOps engineer, as a cloud engineer, they will come here and create a user for you and give you credentials. You understand? Where you will now log in as, so you will see sign up as root, which is your root user. Most companies don't give you access to root account, except you are the principal engineer. That's when you can get access to root account. But when you now see sign up as root, so this is your user. These are all the users I've created over time. Don't mind all these things. You can see 900, and this is over 2 years ago, 40 days ago, 45 days ago, blah, blah, blah. These are users, probably I want to deploy something. So IAM is also good. Now let me give you another scope for your next project. This is where you're going to go. That's the reason why I'm talking about IAM, because this is where you're going to go. You will come to users. Let's say I click one user. Let me use this one. You will see what these are the details of the user, the access key, kini. Me cannot expose my access key for all of them go hack my account. Now let's go to where is that thing? Credentials. Create credentials, create access key. Okay, I cannot create access key in this one because I created two already. Let me use this one. So for your next project, when you are deploying this Dream Vacation app to EC2, you come here, you create this thing. Okay, do you even need to do that? Yes, you do need to do that because, well, you can anyone that rocks your boat. But I'm just teaching you because there's apart from EC2. The reason why I say you need to do that because you can just still use your key pair. You can just still use your key pair to SSH into the application because it's open to the public. You get. But in scenarios where that you set it as open to the public, as SSH open to the public. But scenarios where your application is not open to the public, this is what you're going to do. You create an access key. Create an access key after creating a user. So you create a user, create an access key. You can just use order. So it's asking you what is the use case you want to do. You can just use anyone. You can click on order. You give you rules. Never store your access key in kini or in code. Disable your access key when it's no longer needed. You go to next. Description. As you give you description, once you give you description, once you click on create access key, a CSV file will be created for you. Now that CSV file is what you now go and put in your GitHub Actions secrets, so that your GitHub Actions will be able to SSH, will be able to access your AWS account to do anything. So for example, now you want to deploy to, you don't want to deploy to EC2, you want to deploy to ECS, which is the containerized service, or Kubernetes on AWS. This is what you do. You have to set the credentials so that your GitHub Actions will create a connection to AWS to be able to create that Kubernetes cluster that you need to set up. This is what you are going to do. So yeah, but that's just it. Now, these are users, basically. Now, there are roles. So a user can have a role. So a role is like basically what you call it, a role. You get. So a role now will now have different policies. So it's like dynamic. So a policy is like a setting that you can put on your entity, basically. You understand? A setting a policy is what you can put. So a policy is a JSON document that defines what is allowed and what is denied. So for example, now I'm a cloud engineer. You get. Someone asks me, oh, I want to deploy an application. I want to deploy something into the company's bucket. Now you know that the person has an account. Okay, person does not even have an account. But the person wants to deploy probably a sensitive item in the bucket. However, you don't now want the person to access to touch any other thing in the AWS environment except S3 bucket. It's in the policy that you're going to set it. Now, you're going to create a policy. I can't create policies offhand, but I'm just going to show you how it feels, how it looks. You see, MTN and AWS, they have serious issues. I don't know why, but MTN loads very, very poorly with AWS. But anyways, now you can see choose a service. It asks you to choose a service that you want to work on. You click on S3. I'm teaching you basic cloud engineer work, ND cloud engineer. Now you can see when you do this thing, you will see effect allow. So this effect allow or deny is what it means. So anything you choose deny. Anything you choose is going to deny it. But we're doing allow. So that means this our co-worker wants to be able to what? Upload stuff on S3. You can see manual action, all S3 actions. So if I click on this all S3 actions now, everything concerning S3 leads to, if you want to see all the buckets, you will see. If she wants to delete the bucket, she will delete. If she wants to create a new bucket, she will create. Anything she wants to do, she'll be able to do. But for security reasons, we will not. Now you will see access level list. You can just do all list actions. So she can list all the buckets. She can she won't be able to list because list 2 is also a high security. She may not have that permission. She can read everything in the bucket, or you can set the specific things based on her description. She can write all right action. So let us do read and write. So the read is that she'll be able to read the details of the bucket and she'll be able to write it, but she cannot delete. Okay, there's also delete here, sir. Okay, there's delete as well, but they just say all read and write actions. So she can read and write, but she cannot list. Or rather, okay, since she wants to upload, she can read and write. Then you can also, customize it. She can probably, if you don't want all write actions, you can probably delete object. You can mark the ones that you want. So now it has shown you everything here. You go to next. I'm showing you how to create policies, IAM policies. You go to next. Error. No resource specified. No resource specified. Okay, let's just see all. Sometimes it will just come and change what I don't know. So this resource is now. So from here, object. So let's just keep it as all. Then next, you put the policy name, sister policy. This is my account, so I can name it the way I like. But there are some companies that have naming conventions. They can see allow S3. So it's only limited to S3. Apart from S3, anything this woman touches on this environment will give her error, apart from S3. So we'll do create policy. You see, creating policy, sister policy. I just named sister policy to be funky. Now, we'll now create a role. So this role, after creating a policy, you create a role. This role now will now use that policy that we created. So I'm trying to show you the pattern. S3. Use case S3. So this is our use case for the role. It's the role now that the user will embody. You understand? I'm giving you cloud one. Now you see permission policies. We'll put sister policy. Good. This is the sister policy that we just created a few minutes ago. I is on your role now. You can just put sister role. Sister role. So we'll create a role. Now, I created a role. So we can now attach, let's say, this is my policy now. I can now come here and do add permission. You can see permission policy will do what? What is this thing? Or you use user groups. So this user group now is for if you want to create the same role for multiple people, you use user groups. So let me use this users again. User. Ah, add permissions. Attach policy. So this one is attach. Okay, we can attach policy to a user. Yep. This one is sister policy to attach policy to a user. So you can see this my user has the attached policy. I'm trying to figure out that rule. I can't. I've not used role. So for personally, what I use roles for is to attach it to, for example, now I want to attach the like a resource. So if I want my virtual machine to assume a role, that's when I now use roles personally. So attach this role to it. Now this user group now I can create a group. Can create a group. Let's say engineers. Let's say engineers, and now add all these my people here, my brothers and sisters. Let me just say that these are all mine though, but you can also attach the policy. Then you now attach the policy. So the role is sister policy. So it means every single user, and this is the best way to attach this thing. Every single user here will have this sister policy. So you can come into a company now, they'll tell you, oh, join XYZ role, join the engineers role, and you get it. So that's all about IAM basically on a light note. Um, what else we're going to talk about? VPC. So VPC. After VPC, we'll call it a night. Then on Friday, we'll talk about the rest so that you understand the assignment very, very well because I'm basically giving you cheat code, basically. Now on IAM, you can also create policies using the JSON files. But that one will be a bit more up there for you if you don't understand the underlining technology. That's why I did not use JSON to create them. So let's talk about VPCs. VPCs are complex. I'm not going to create a VPC. I'm just going to explain the concept. So VPC is what they call a logically isolated network within the AWS environment. You get? It's like, okay, I want to create a resource, but I want to create a network that the resource will run on. Ideally, when you're creating your environment, you use what they call custom networks. You understand? You can create it, you can use, but custom network is not good for long, especially when you're talking about security. You understand? But but um oh god, I'm going to lose my train of thought. Yeah, so you create a custom network. Now, VPC on its own is your own private cloud network within AWS where you define your IP addresses, you define the basic networking behavior. So when you're creating your VPC, you create it, oh, this is where my resource will stay, this is the network is going to connect to this. Then there are subnets. Subnets are subdivisions of your VPC. Subdivisions of your VPC. It can be public, it can be private. So public is if you want your resource to be accessible to the internet, you create a public subnet. Well, probably I won't create VPC in this class, but on Friday we'll delve into it so you understand that particular system. Then private subnet. If you now, for example, now I want a resource that people can easily reach from the internet. A typical EC2 instance that someone can easily just ping and enter. I put in a public subnet. By default, each VPC has a public subnet. By default, like if you create a new VPC, it comes with a public subnet. But but there are some resources that you don't want to access to the internet, like database. Do you want the database to be reached by internet people? No. So that's where you create what they call a private subnet. I'll show you how to do that. Then there's also an internet that subnet here. So you can see your VPC. These ones are just available subnets. These are all the default subnets. So there's default VPC, which is custom to every, when you log in. Then there are the subnets here. Then there are the internet gateway. The internet gateway is what they call the internet gateway. Is a part. So this is what makes your public subnet work because it is what brings in the people from the internet to your application. So once you connect your internet gateway to the subnet that you created, that's what makes the public subnet. Basically, it's a gateway that connects your VPC to the internet and is needed for public subnet. Now, there's also what they call a NAT gateway, which is Network Access Translation Gateway. It is now what makes your VPC, your subnet, a private subnet. It allows private subnet to access the internet for resources and updates, but does not allow people from the internet to access these resources. So if you're building a server, if you're configuring a server where, okay, you want to be constantly updating the server, but you don't want people to access the server, you use a NAT gateway on the server instead of on the subnet instead of internet gateway. These NAT gateways are useful to create databases. You understand? So that people from the internet cannot access those databases. Then there's a route table. So the route table is like a traffic controller. Your traffic controller tells you, oh, this is where your traffic should go. This is where your internet should go. So your route table is what basically leads the internet gateway and the NAT gateway. Oh, collect from here, don't collect from here. Network ACLs are like firewalls, but they operate at the subnet level. So unlike security groups that operate at the instance level, network access control list operates at the subnet level. So it does not allow internet, it controls traffic within the subnet. I know that's a lot to understand right now, but I feel like this will be a basic part of our hands-on on Friday. That being said, I don't want to explain more because you just fall into a deeper well of confusion because networking is a lot. But at least I've explained EC2, I've explained S3, I've explained IAM, my VPC. The next one is RDS. These are important, very important. So RDS are the database service of AWS. So if you want to spin up any type of database, big, small, large, thin, come to RDS and spin it up to database instances. There are no database instances here because who do I want to create database for? I don't have money. So you can come here, you can create database. I'm not going to create one because databases are expensive. You can see different databases. Aurora, these two now are several databases. Then there's the MySQL database, there's the Postgres database. So it depends on what your client wants. Oh, I want to deploy a MySQL database with X so gig RAM, so storage, kini, you come here. I can come here and create a MySQL. You see the whole settings, production, dev test, free tier. So I'll use free tier. If you are doing anything related to for testing, but for production, use production. You can see now single AC means that to be in one zone, it will not be in multiple zones. It's good for free tier, but it's good for free tier, but on production you have to make it multiple zones so that if one crash, the other one can come off. So you can see primary instance and standby. That's the good part of the database. You can create one in one corner, one availability zone, create another in another availability zone. When I'm setting up, when I was doing the hands-on, I'll talk more on regions and availability zones as well. Then there's master username. This is where you set your username. Then storage. This is where you set your storage. So allocated is 400 gig by default. You can increase it to as high as 1000 gig, which is 1 terabyte database and the rest. So after you have done with everything, they'll give you a pricing under. So it's whether you agree. This price is per month. Note. This was the price I saw my 23 or 25K USD when I provisioned it. And yeah, that's just it. It's very cloud computing is it's actually simple, but it's not as simple as people just think, oh, because you are pressing X, Y, Z, it's easy. You know, it's not actually because you have to think of the best. You have to one thing in cloud computing is that your first factor is security. I want you to write it down. Security. After security, you're talking of high availability. High availability simply means will this thing be on 99% of the time? What will make it off? How can I fix that before even turning it on? That's what high availability is. Then there's disaster recovery. Disaster recovery is this resource I'm provisioning now. If something happens now to where this resource is in America, is there a plan to migrate these resources to another resource while still maintaining uptime? That's what they call disaster recovery. What else again? Cost optimization. These resources that I'm creating, in as much as you are creating them, for user, how will I maximize cost? How will I minimize cost while maximizing the benefits? So these four things now are what you should consider as a cloud engineer. That's what they call you a cloud architect. When you say, "Oh, I'm a cloud architect," because when a client needs resources, your own is to provision it according to these four pillars: security, high availability, disaster recovery, and what? Cost. Once you can get the best, once you can go through these four pillars and get the best architecture, you're good to go. So yeah, I think that I'm done for what I need to do today. On Friday, we'll talk on hands-on. I've already shown you how to create an EC2. Next, I'm going to show you what I'm going to show this time is a more broader view of how to create a VPC that will house an EC2. I'm not going to put you through those stress but for your task, you just do a default VPC to deploy an application. For this one, I'm going to create a VPC from scratch, a networking, show you how all the networking are passed through. Then from that network, I will now create a what? I'll now create an EC2 instance from it. So yeah, any question? Hmm?
Good evening, sir.
Good evening.
All what you have explained concerning EC2, can we perform safety in Azure environment?
Yes, now they're all cloud providers, but there are different workarounds around it. But the underlying concept is the same, and
Okay.
the user interfaces as well are also different. For example, now we call our own AWS calls their own S3 buckets. Azure calls their own containers, block storage accounts, so containers inside the storage account. Google Cloud call their own Google Cloud Storage. EC2 on AWS. EC2 is on AWS. On Azure is virtual machines, I think. Yeah. Then Google Cloud is Compute Engine. Google Compute Engine. So yeah, they're all different. Then the concepts are the same. The work setups are the same. Just the user interface and the workarounds basically. Any more questions? I'm not hearing anything. No. Any more question? Does anybody understand what I've been saying since? Karen, do you have any question?
No, I don't have. Good evening, sir. I don't have any questions. Possibly, maybe after, yeah, because I'm really drinking time. I don't
You still what?
really
I can't hear
understand. I
you
go
clearly.
back watching videos. Can you
I
hear
can
me?
hear you now.
Yeah, I said most times during the class, I don't really have questions until I go back watching the video again. Then I can have questions, right? So I just follow through and all, then try watching again to see. Yeah. So I don't have any questions.
No problem then. So the person I wanted to talk about, I think I will not because so yeah, you know. All right.
Sir,
So if there's no question.
I have a question, sir.
Okay, go ahead.
Sir, no, I'm noticing some similarities between launch templates, AMIs, and I think snapshots.
Okay.
What's the major
Snapshot
difference?
for snapshots are for disks. You understand? So if like now you have a hard drive on your volume, if you want to create a backup of that hard drive, you create a snapshot. You understand? Launch templates are if launch templates are pre-creating an EC2 instance. For example, now you have some configurations that you want to automate, you want to like automate them. So for example, I want to create a server to I want to create a server to install Nginx on the server. But I don't want every single time when I open that server Every single time when I create a new server, I'll now go and start writing configuration from scratch to install Nginx. What I'll do is I'll create a launch template that contains the Nginx configuration, so that every time when I want to create an instance, instead of me to just create the instance like that, I'll use the launch template to create the instance. Then the instance will come pre-installed with Nginx configuration.
Okay.
You understand? Do you understand those two first?
Yes, I understand those two.
Good. Now AMIs are like templates. So there are two types of AMIs. There are AMIs are already in the marketplace, which is what we use as operating system. Linux AMIs, Windows AMIs. When you have a server, probably a server that you have created from probably a launch template. When the server is already running, you want to get an image of that server. You now create an AMI from that server. The whole server configuration, not storage. You understand? You get?
Okay, thank you. Yes, I get that. So I also have another question. Anytime I'm using anytime I SSH into, let's say, an instance now, probably I now switch off my system and I switch it on back. The next time I'm trying to SSH into it, I have to go to the security group. Let's say I'm using in the security group, I'm using my IP.
Don't use my IP. The reason why I tell you to do, the reason why I say you should not use my IP, because Nigerian internet service providers used to Jones IP address a lot. So once you use my IP, there's a high chance that it will have switched to some certain level. So what will be accepted will be different. You understand? What will be accepted, what will connect to SSA will be different from what you already set. Sometimes you may see that it's the same, but it just happens like that. So I don't really use my IP. That's why most times I just use VPN, but that's like a complex setup. You use like client VPN and stuff just to connect to your internet. That's if you're doing secure stuff. You get. But if
That's what I'm
you're not doing secure stuff, you can just leave it open to the public. Then
okay. Because I'm thinking opening it to the public, is it the best security practice?
if you're using it to practice, it's not the best security group, but if you're using it to be practice, why not? You can just use it and practice. Then if you're trying to like build something for a client, then you should consider using client VPN, setting up a VPN for the client that the client can use to SSH into the server. You understand?
Yes, sir.
So they will just only when they connect to the VPN that they can enter the server. You understand? Or you can use all the session manager or stuff. I've not used them before. Just do research. There's some tools like session manager that can use to work around all those stuff without SSH. But SSH is like fundamental knowledge level. You understand?
Okay, sir. So one other question is, this one is pertaining to the last assignment.
Okay.
So dispatch.
Eh?
I said the workflow dispatch that we used in the last assignment.
Uh,
I'm thinking, is it really necessary? Since
no, it's not. You can decide not to use it. I just prefer using it, but you can decide not to use it.
I'm just thinking, is there really any reasoning behind it? Because if you see similar, if you want it to be automated.
Yeah, most times you want to push multiple things before building. You understand? Probably you can work in an engineering environment where they will just tell you they have to review the code before it passes through the pipeline. You understand? That's where workflow dispatch comes in. So that when they have done all the review and everything, then you trigger the workflow and to build. You get?
Okay.
It depends. You can use it, you can remove itself, and so once anything you push, it will build automatically. You understand? It's just use cases. You get?
Yes, sir.
Any more questions?
Yes, good evening.
Good evening. No. Yeah, this
Yeah,
is my guy. He has opened himself up. Thank you, Jesus. This is the first thing I've been talking about since. But continue.
please, I just need to be clear on the difference between roles and policies?
Okay, so policies, on that question, it's actually a very, very good question. So policies are what defines the action, like that definition. Oh, the user or the action or the user or the action. The user, sorry, or the resource can be able to do this, cannot be able to do this. That's a policy. You get.
Okay.
The role is the assumption of that policy. So, for example, I want the user to assume such policy. I put it to a role and I attach it to a user. But this particular stuff, now I don't know, probably I've not used AWS in a while. So this setup now, I can attach a policy to a user directly. But when it now comes to a resource, you can now attach it to a role, then attach it to a resource. For example, you may not want a user. You may not, okay, for this scenario I did now, we're setting it for a user that wants to access S3 only. You can be asked, okay, create an EC2 instance. That EC2 instance, from that EC2 instance, I should be able to download S3 files. You understand? I should be able to download files from an S3 bucket inside the EC2 instance. That is where you implement a role that will assume a policy to get objects. So when you create a policy for get object, attach it to a role, that role now you will now attach it to the EC2 instance. So when somebody enters into an EC2 instance, they can get objects from the bucket inside that instance. So that's what a role and a policy is.
So that means roles are not associated with a specific user or group.
No. Roles are not associated with specific user. Roles can be any user or any resource. Have it at the back of your mind. Any user or resource, not just a user. Resource can be Kubernetes. Resource can be EC2 instance. So if I want my Kubernetes setup now to access something in my S3 bucket, I put the permission in a row and attach it to my Kubernetes, my ECS. You understand? That's what the roles are for. Is it clear?
Okay. Yes, it's clear.
Okay. This is my guy, oh. This is the guy, oh. This is the guy. Thank God he has talked today. Wilfred.
We don't mark in face.
This guy always has 100. Oh my, as in, one of the mark in assignment that they say yes. So I missed his name in the last class, but I saw this last setup. I said no, I must mark this guy's name. He's doing well. He's doing well. So yeah, that being said, thank you very much. You should try your best, man. We're entering project phase very soon. So everybody will be split. Everybody will be split into people that make it to stage 8 will be split into groups to work on a live project as per a live project that is solid. And you can put on your resume that, oh, we worked on this project. You can even put it, oh, I worked at XYZ company where we build this product. Yeah. So that being said, I'm about to let you know to try your best and reach stage. Try your best and reach stage 8. No, it's with everybody. So you are building a product. They'll bring one front end, one back end, one DevOps, one product designer, one QA. What is it? One QA. Put it in one group. Now you will work together as a company. As if you were working in a company, you will do daily stand-up every day to work among yourself and build this project. And at the end of this class, you present this project that you built. That being said, why is Karen? Why are you panicking? It's fun, no. You won't get to hear my voice again. What you just do is you thought you will have a project lead among yourselves and just get it done. Yeah. So that being said, say I'm doing well. Okay. Thank you very much for today's class. Let me stop recording.